Okay, so I wish a very good evening to all of you. Uh, I am Saurabh Sakre. I am basically a civil engineer having master's degree in environmental engineering, and I am taking this subject from from August 2019 batch itself. So you are the third batch, I mean third group of batch for which I'll be taking this class. So in last 3 4 years, whatever feedback I have received from other students, that's I have that all that I have included in this particular slides. And still, I request all of you to be cautious, be attentive, and listen to all the concepts and logics carefully. And if you wish, it can be improved. For sure, I will improve afterwards. Okay, so first we will start with the basic terminologies we use in statistics. So I will not start with a basic definition of statistics, what statistics means, what is its textbook definition and all. I will just take this through take you point by point in this subject. So first, we will see some basic terminologies we usually use in statistics. So there are total 5 terms we use. First is population, second is sample, third is parameter, then statistic, singular. So here you can see bracket intentionally we have mentioned singular, means it is a single word. It is not plural. Statistic and then variable. So now one by one we will read it and I'll show you one figure and we will try to understand what does this definition means. So starting with the population. So what does population means? Population is all the members of a group about which you want to draw conclusion. Right. So so in statistics, why we apply statistics? We apply statistics so that we can draw some conclusions out of it and we can make some decisions out of it. So what is population? Population is all the members of a group about which you want to draw conclusion. Second one is sample. Sample is what? It is a part of the population under consideration. Okay, so sample is what? The part of the population selected for statistical analysis. Okay. Now see here. Suppose I have a river stretch. I have a river stretch whose length is L, as you can see here, length L and width is B. Okay, I hope you are able to see the figure. Width is B, length is L. So my task is to see what is the water quality index of this particular stretch of river, right? What is the water quality index of this particular stretch of river? And I will see to it on the basis of DO in that particular stretch of river. DO is dissolved oxygen. Like the more the dissolved oxygen in that particular stretch of river, the good is the water quality. Okay. So when I'm seeing this whole stretch of length L and B, I will call it population. Okay, this whole stretch, forget about S1, S2, S3 and S4 now. This whole stretch L and B, when I'm considering full stretch, I will call it population. Now read the definition. Population is what? All the members of a group about which you want to draw, you want to make statistical analysis. So that is what my whole stretch is. Now, what does sample means then? Sample is the part of the population selected for statistical analysis. Now, you yourself think it is not possible for me to take the whole stretch of river with me to the lab, right? I cannot take all of the water which is stored in this length L and width B to the lab. So what I will do? I will collect some samples. So here I have collected S1, S2, S3 and S4. Okay, a part of the population. So the part of the population I call it sample. Sample is what? The part of the population selected for statistical analysis. Okay, I hope these two definitions are clear to you. Now we will see the third one. Third one is uh, on the third one is a point on which we will be describing it. That is parameter. So what does a parameter mean? A parameter is a numerical measure that describes the characteristic of the whole population. Okay, here you have to keep this in mind. Parameter is for the population and statistic is for the sample. Okay, so I'll just read it and you just try to understand. Parameter is what? A numerical measure that describes the characteristics of the population. And what is statistic? It is a singular word. A numerical measure, this is also a numerical uh, measure that describes the characteristic of the sample. So parameter is for the population and statistics is for the sample. You can also remember like this: P for parameter, P for population, S for statistic, and S for sample. So in this case, my whole water quality index, which I will be reporting for the river, for the whole river, it is my parameter. Okay. Whole water quality index, which I'll be reporting for the whole stretch of length L and width B is parameter. And the statistic or the technical part which I'm measuring in a sample is called statistic. It is called statistic. But one thing I would like to tell you that most of the times nowadays in last 10 to 15 years, we only use word parameter. We have almost mixed statistic and parameter. But you keep this in mind when you are doing an analysis on a small chunk. Okay, when you are doing analysis on a small chunk, that is called statistic. But when you are drawing a conclusion using that sample for a whole river or for a whole population or for a whole region, that time you will call it parameter. Okay. So I hope these four definitions are crystal clear to you. Population, sample, parameter, statistic, singular. Now, fifth one, variable. Now you yourself think this WQI, water quality index and statistics will not be same throughout the river. Here it is different. If I consider another stretch after 1 kilometer, their WQI will be different, right? At third stage, it will be different. So it is varying, right? It is varying. It is able in varying. That's why it is called variable. Okay, so parameter and statistic, it together it is called variable. Okay, since it has the capacity to vary with time, with location, and with some other dependent parameter also, it has the capacity to vary and it is able in varying. If you see from English perspective, something which is able in varying. That's why we are calling it variable. Okay. So I hope these five definitions are crystal clear to you. Aswati NV, are you there? Adira VC, are you there?
Yes, sir. I'm present.
Okay, so Adira, can you just tell me the difference between sample and population?
Um, okay, sample is a part of population that we use to take analysis. Since population is huge, we cannot analyze the whole population.
Okay, some more?
Sorry, sir.
No, means you can describe it little bit more.
Okay. So sample, since the population is huge and there are like it is nearly practically impossible to like take the whole measurement.
Yes,
So we actually divide it into different samples and we take the measurement and it will be like the measurement will be like it will be equalized to population measurement.
good, good, good. Aswati NV, are you not there? Okay, no issue. Andrew, you able to hear me, Andrew? You may be able to hear us, but we are not able to hear you. Okay. Aarti Krishnan, are you there? See, it will not be like a monologue from my side. You can ask previous students. I regularly interact with all, and you have to answer me. You cannot keep quiet all the time. Okay. Aarti Krishnan, are you there?
Hello, sir. I'm here.
Yeah, yeah, yeah. Aarti,
So there is
can you
some
define?
range issue, so I'm here. Hello.
Okay, okay. I
So
hope
actually, I
you
am
are
in the
back to
middle
Trivandrum.
of traveling, sir. I no, sir. I didn't reached. I'm in
Okay,
middle
okay
of
then.
traveling.
Okay, no issue, no issue. I'll ask someone else.
Okay.
Uh,
Okay, thank you.
Anjana? Anjana?
Hello, sir.
Yeah, can you please define what a variable is? Okay. Archa? Delna TS, are you there?
Sir, variable is that can be measured like that can means assuming by different values. From this, we can measure a variable.
Okay, but why it is called variable? What are the what are all the factors which make it
Because it
vary?
is varying, that's why it's called as variable, like our height, age, that is varying
Hmm.
like that. Uh,
Yes, yes. Okay, okay, okay. So good. We'll proceed. Now, if you see statistics, there are two types of statistics we use. Okay, there are two types of statistics which we use, or we can say that academically, there are two branches of statistics. First one is descriptive statistics and second one is inferential statistics. Now we'll just see what does it means by descriptive and inferential. So when I say descriptive, the name itself indicates I'm only describing some data. Okay, I'm only describing some data, like what is the minimum value in that, what is the maximum value in that, what was the average when I analyze this data, and what is the standard deviation. All these things anyway we will see in subsequent slide. So in descriptive statistics, I'm only describing the data which I have analyzed. But in inferential statistics, what I will do, using that sample, okay, using that sample, I will draw conclusion for the whole population. And that statistics, when I'm applying to draw conclusions about the whole population, is called inferential statistics. Okay, it is called inferential statistics. The name inference itself means grammatically from an English language perspective to draw conclusion using a precursor set of events with some technical help, with some technical or mathematical help. That's why it is called inferential statistics. So inferential statistics is what? The branch of statistics that analyzes sample data to draw conclusions about a population. In this, we read probability distribution and hypothesis test. So here, if S1, S2, S3, and S4 are my sample, so I will compute a statistic and I will first apply descriptive statistics in that. I will say that S1 was the minimum, S3 was the maximum, the average was 5 milligram per liter of DO and all. But when I'm reporting WQI, actually I'm applying inferential statistics. So when I'm working in the sample, it is descriptive statistics, and when I'm working for the population using the sample, it is inferential statistics. I hope this is clear to you. Now, now, now we should understand what types of data we encounter in our daily lives. In our daily lives, and when you are doing your PhD or when you are doing any type of statistical analysis, what type of data we encounter. So this is very important. You please understand it. And in last batches which I taught, many of them has told me afterward that after this class only we were actually realized that what type of data we are generating in our experiment. We were simply doing experiments and generating data. They have even published paper also. But the minute things, the deeper insights, they would only come to know when they did some introspection that what kind of data we are generating. So we'll now understand. So firstly, we can divide data in two types. First is categorical and second one is numerical. In numerical also there will be two types, discrete and continuous. So what does categorical data means? Categorical data means it represents a group or categories. Okay, mostly theories. So examples are like car brands, Audi, BMW, etc. Sometimes if you are doing a survey or something, it's answering yes or no. And if you are doing a population survey, male or female, this kind of data when you generate, it comes under categorical data because I'm categorically saying that yes, it is this many are female, this many are males. Okay, now this is about categorical data. Now in in the second case, there will be two types of data we encounter. First one is discrete, second one is continuous. So now this difference you should understand. Discrete means discrete data comes from counting process. Okay, discrete data comes from counting process, like number of newspaper or magazines subscribed. Suppose I ask you how many magazines or how many newspaper you have subscribed to. You cannot answer me 1.5 or 1.7. Either one newspaper, two newspaper or three. One magazine, two or three. But you cannot answer me like 1.1 magazine I have subscribed or 1.5, right? Those kind of data, which is discrete, which cannot take any other value between a particular interval. That kind of data is known as discrete data. Okay. That kind of data is known as discrete data. Then continuous. What does continuous means? It is like measurement of weight or height or experiment. Like suppose I am measuring my weight. So it can be 75.1 also, 75.115 also, 75.2 also, 75.3 also. If I go to fourth or fifth decimal, there also it can take values. So that kind of data is known as continuous data. Okay, so whenever you are doing some experiments, your number of experiments may be discrete, but in that discrete, you are generating continuous data. And when you know what type of data you are generating, it will be easy for you to apply statistics. I hope it is clear to you. If it is not clear to you, listen to it cautiously, because anyway, I'll be asking you after this, after some time. So, so I hope discrete data and continuous data is clear to you. Just to make you clear, when something comes from counting process and you cannot take value in between, that data is known as discrete data, as the name indicates, and continuous data is something which comes from measurement of weight or height or experiment, and it can take any value between two variables. Okay, that is known as discrete or continuous. So I hope up to this point, types of data is clear to you. Second, now we will see types of data based on its level of measurement. Okay, based on its level of measurement. So based on this, there are two types: qualitative and quantitative. Okay, levels of measurement, qualitative and quantitative. In qualitative, there are two types: nominal and ordinal. Nominal, ordinal. In quantitative, two types: interval and ratio. Okay, interval and ratio. Now we will see one by one what these data types means. In qualitative, we will see first. So what does nominal data means? So nominal is basically a type of categorical data only, but it will have something different. Like nominal data is something that cannot be put in order, like car brands, Audi, BMW. I can also say BMW, Audi, Maruti, and Volkswagen. I can say Volkswagen, BMW, Audi. There is no order in that, but still they are what? Car brands. So this kind of data is known as nominal data. Then what does ordinal means? Ordinal means those are categories only. Those are theory only. But I can put it in order. Okay, categories that can be put in order, like a rating of food. Most negative to most positive, disgusting, unappetizing, neutral, tasty, and delicious. Okay, so any categorical data, when I'm putting it in order, it is known as ordinal. Okay, so accordingly, you can rate our Miss Canteen and let me know later on. You can type it in the chat box also. Okay, so I hope nominal and ordinal is clear to you. Now we will see interval and ratio data. So in interval and ratio, their difference basically or primarily comes from their ability to dip below zero. Here you can see their ability to dip below zero. Okay, dip below zero. So 1 minute. Yeah, Srijit. 1 minute. Only signature, na? Subject expert. Yeah. So the interval and ratio are basically differentiated on the basis of their ability to whether they can dip below zero or not. Now we'll understand. Interval. So an interval scale holds no true zero and can represent values below zero. Like example, temperature. Temperature can be below zero and can represent minus temperature. So temperature data is basically a interval quantitative data, right? Temperature is interval quantitative data. And what does ratio means? Ratio variable never fall below zero, like as an absolute zero or character of origin. When there is a character of origin, that data is ratio data. Simply height and weight cannot be zero or below zero, right? I cannot say my height is minus 175 centimeter or something. So this is the difference between these are the types of data based on the levels of measurement. So I hope types of data based on categorical and numerical plus types of data based on levels of measurement, qualitative, quantity, all things are clear to you. Okay. Okay. Anyway, I'll ask after 5-10 minutes. Be ready. Okay. Now, suppose I wish to make graphs out of it. I wish to visualize this data. How I will visualize and what type of charts or what type of graphs I will use. So mostly we use four types of graphs, four types of representative techniques, or four types of uh, visuals. I would say four types of visual in this. So first one is frequency distribution tables. So when did we use it? Frequency distribution table show the category and its corresponding absolute frequency. Like suppose I have 124 Audi, so I'll write Audi, then 124, BMW 98, Mercedes 113. So this we use when we have in one category n number of elements. Okay, frequency distribution tables. Second one is bar chart. Bar charts, when we will be using it, bar charts are very common. Each bar represents a category. On the y-axis, we have the absolute frequency like Audi 124, BMW 98, Mercedes 113. Okay, like that. Frequency distribution table, bar chart. Third one is pie chart. So pie chart we use when we want to show share of something out of 100 or out of a fixed value. Like suppose I live in Trivandrum now. So in Trivandrum, how much area is covered by water body? How much area is covered by built up? How much area is covered by road? How much area is covered by mixed vegetation? How much area is untouched or barren land? How much area is only open land? So the total area of Trivandrum is fixed, right? So total area of Trivandrum is fixed. In that, what all classes are there? If I want to show the statistics, I will use pie chart. Suppose you are you are doing some kind of resource recovery analysis, and you want to see in 1 kg of e-waste how much of different elements are there. In that also you can use that. That's not an example only, but whenever you are encountering a data in which base value is fixed, or base value is fixed, or the denominator is fixed, remaining you can show it in a pie chart. Last one is the Pareto diagram. So in the Pareto diagram, what we'll do, the Pareto diagram is a special type of bar chart where the categories are shown in descending order of frequency, and a separate curve shows the cumulative frequency. Means first I will arrange it in ascending, my values I will arrange in descending order. Here you can see Audi was the highest, so 124, Mercedes was second highest, 113, and BMW was the lowest, so 98. But the line I will make cumulative of this. So I will be able to see a clear picture how my data is decreasing and how it is increasing. And wherever there is some intersection. Okay, actually you may not be able to understand right now, but since I use statistics a lot, I can tell you this kind of graphs will tell you wherever data is getting intersected. And these things will give you a lot of insights about the data. It even after in descending order, even after in arranging order, if data is clashing somewhere, means from there I can draw some more insights. Okay, so in those kind of situations, these graphs are useful. Okay, we'll proceed. Now, suppose I have numerical values with me. I have numerical values with me. In those kind of cases, we draw histogram and histogram relative frequency. Histogram is nothing, but it is a bar chart with different intervals. Okay, so here you can see in this table you can see here. Here, let's say my interval is starting from 1, ending at 21. Second one is starting at 21, ending at 41. Then 41 to 61, there is an interval of 2020. In that 1 to 21, I have observed two values. Okay. In that 21 to 41, I have observed 4. Then 41 to 61, I have observed 3. So likewise, I have prepared one table, and this is its relative frequency, means out of 100, how many times I have observed it. So with this, what I can do is that here you can see now. First one was 1 to 21, right? First one was 1 to 21. Here you can see in that I have observed 2. I have observed 2. So you can see here 1 to 21 and it is ending at 2. Okay, histogram. Then my second value is 21 to 41. In that I have observed 4. So 21 to 41, I have observed 4. Here it is matching with 4. Right. I know I can very well understand from your perspective that I am showing you an example with a general graph. But when you are doing your data, when you are doing your PhD, you can very well come to me with the data and I will suggest you what type of representation you should use so that it will convey the scientific meaning of your research. First, you try at your level, then you can very well come to me. But now understand the basic of the graph. Okay, in that 41 to 61, it is 3. It is 3. Now, this is only a histogram when I am limiting myself up to frequency. Okay, this is just a histogram. When I am taking relative frequency in account, I will prepare a histogram relative frequency. Okay, I will prepare a histogram relative frequency. So here 1 to 21, 10% of the time. So it is stopping at 0.10. 21 to 41, 0.20. Okay, 41 to 61, 0.15. Like that, I can create one histogram relative frequency. So here I will directly see number and here I will see frequency, that how many times it is repeated in that particular graph. Okay. Now, sometimes we will have more than one variable in our experiment or in our analysis, whatever we are doing. So in those kind of cases, we make cross table or contingency table. Okay, this table what you are seeing, it is known as cross table or contingency table. So actually, this table has one advantage. In this case, the diagonal sum will always be 320, 213 and 382 in the total will be 915. From here also it will be 915. So in this case, we will be able to have a cross check on that. That's why it is known as cross table or contingency table. So here you can see type of investor or investor, stocks, bonds, real estate. Then investor A, investor B, investor C. So investor ABC total in stock 320. Investor ABC total in bonds 213 and the sum total here. So why we created this? Actually, this is a simple example. So you may perceive it as a very simple table, but when you are dealing with large data, contingency table is very useful. So here 365, 340, 210 will. Someone is muted me. I think some of you don't want me to speak. Anyway, so Shravan, I hope not much portion is left. Okay. Okay. So in actual, this kind of table is very useful when you are dealing with large set of data and there are more interdependent variables. Okay, in this kind of cases, what we do is that we make side by side chart. So here you can see investor A. Investor A was somewhere around 96, so it is here. Then B, then C. Then stocks, bonds, real estate, stock, bond, real estate. Like that, we make a side by side bar chart. So when you are generating some data in your experiments where 2 or 3 variables are dependent on 2 or 3 variables, you can make a contingency table. And for that contingency table, we can create graphs and then we can apply inferential statistics. So I request you that from today itself, you just observe what kind of data you are encountering in your PhD work so that we can very well have a direction now itself that how we will be statistically representing your data. So with this basic terminologies are over, then I'll start. Before that, Aditya S, are you there? I told you I will not be. It will not be like a monologue. You have to interact with me. Aditya, yes. Are you there?
Yes, sir.
Okay. Oh. Aditya, not Aditya. It is Aditya. Is it?
Yes.
You able to hear me?
Yes, sir. It's audible.
Yeah, but you are not audible properly. Okay, no issue. Aparna SM, are you there?
Yes, sir.
Okay, so can you please tell me a difference between ordinal and nominal data?
A nominal level represent categories that cannot be put in any order. Ordinal
Okay.
categories that can be put in orders.
Okay, good. There is one addition from my side. I forgot to tell that time. It cannot be put in order, or sometimes we don't need to put in order. So that data also will come in. Like brands of car, I may need not put in order. So that also I'll categorize in nominal. Okay, good. Devika Yadav, are you there? Devika Yadav.
Yes, sir.
So can you please tell me difference between interval data and ratio data?
Sir, interval data in which we can put in a category wise.
Oh,
And ratio data we cannot put in category wise.
actually, that is nominal and ordinal.
Okay, so we do.
Okay, no issue. You just see. I'll share the recording. You just see. Then we'll see. Okay, Devika.
Yes, sir.
Nayan Dev Madhavan, you able to hear me?
Yes.
You able to hear me, Nayan Dev?
Yes, sir. Yes, sir. I can hear
So
you.
yeah. Okay. Can you please just tell the difference between discrete and continuous data?
So discrete data means like whole numbers, maybe because like we can only count them. And when it comes to continuous, it can be like they will have decimal points. Like a lot of data will be there.
Okay. Good. Nivedita Nayak, are you there?
Yes, sir.
So can you please brief the difference between descriptive and inferential statistics?
Sir, in descriptive, only describing some data. And in inferential, we can conclude, we can draw conclusion from that sample data.
Okay. So
Sir,
what type of things? Go ahead.
For descriptive, we can say the maximum value, minimum value, standard deviation, etc. From inferential statistics, we can analyze the sample data, and we can draw the conclusion from about that population.
Okay, good. So for the next batch means Vismita, Vishak, Sumita, Shruti, Sridevi, Sophie, Mariam, Shiva Krishna, Simi, Achana Kunju, Saranya Devi, Sangeeta, and Ria Martin. I'll ask you after some time. Be cautious for next 10-15 minutes. Okay. Now we will start the second PPT. Okay. So the slides are visible?
Yes, sir.
Okay, great. So now we will start descriptive statistics. Okay, first we have understood what are the basic terminologies we use in statistics. Then we have seen types of data, and tomorrow I'll ask you, and you have to, not tomorrow, maybe next class, I'll ask you and you have to tell me about your data and justify it, what type of your data is. Okay, you have to answer me, whosoever I ask. So you just ponder over it and we'll discuss in next class. So now we will start descriptive statistics. Now, what does descriptive statistics means? I told you already, descriptive statistics is what? The branch of statistics that focuses on collecting, summarizing, and presenting a set of data. Example, minimum value, maximum value, average or standard deviation. So what all we read in descriptive statistics? First, we see measures of central tendency. Then we read about measures of dispersion or variability, partitions, and measures of symmetry. These four things together constitutes descriptive statistics. I am not including graphs here because graphs are many times, sometimes we prepare, sometimes we don't. So I'm not including graphs here, but these four things usually we read when we discuss about descriptive statistics or we apply descriptive statistics on our data. Now, first, I would like to give you understanding of measures of central tendency. We are starting with measures of central tendency, the first one. Okay, the first one, measures of central tendency. Okay, so I would like to give you the understanding first. Definition anyway we will see. So what does central tendency means? First I'll read and then I'll give you some 2-3 real life examples, maybe from list also, then you will understand. So measure of central tendency is what? A measure of central tendency is a typical value around which other figure aggregates. Okay, means it will be a value around which all other figures will be aggregating. Okay, means they will be try to agglomerate of that near that particular point. Okay, that is what is a central tendency. Then measure of central tendency refers to average of value of the data. If I say numerically, it refers to the average value of the data. Now, first point was related to theory. We just say that okay, central tendency is something in which it is a typical value around which other figures try to aggregate. And second one is a numerical value. We call it average. Now, third one is what? It may be a single value. Okay, an average is a single value within the range of the data that is used to represent all the values in the series. Means I'll be saying one value only, but it will represent all other values. Okay. Since an average is within the range of the data, it is sometimes called a measure of central value also. So measures of central tendency is also known as measures of central value. Now I'll just give you an example. Suppose we are going to conduct radians in list. I know some of you may be in the organizing committee also, and we are giving t-shirts. Okay, we are giving t-shirts. So of course, majority of the t-shirts will be in a particular range. Let's say 39 to 42 or 40 to 42. But some will be outliers. Some will be very small and some will be very bulky. Only selected kind of people. But if you see, majority of them will be in that value, like 40 to 40 centimeter. 80% of the needs will be covered. So that 40 to 40 centimeter is a measure of central tendency. If you fulfill that, 80% of your task is done. Okay, that is what measure of central tendency is, and that 40 to 42 is your average value. Okay, that is what also called as measure of central value. And one more example, we can say like that. Suppose there is a class teacher, let's say me, and you are students, and I have conducted one exam, and our beloved director has asked me the result. So I cannot say that Ashwati NV this much, Adira VC this much, Anjana this much, or Nayan Dev this much. I will say, sir, result was 81%. Means out of you, 81% has passed the exam. So that 81% is measure of central tendency or average value. I know you are seeing this from a long time, but I'm giving you an understanding from another perspective. That will be very useful for you to see data in real life. Okay, that is what is known as measure of central tendency. I hope it is clear to you. Okay, now when we talk about measure of central tendency, usually we calculate 5 things: mean, median, mode, harmonic mean, and geometric mean. Okay, mean, median, mode, harmonic mean, and geometric mean. Okay, so in our case, I'll be only covering mean, median, and mode. Harmonic mean and geometric mean I'll not cover. because these three are mostly in use. So before I start with mean, median, and mode, I would just like to discuss with you one important definition. This definition is of an outlier. Okay, just now I gave you an example that if you are conducting radiance in NIST and you want to order t-shirts, 80% of the students are having size between 40 to 42. But some will be very small, some will be very big. Okay, due to their body structure or due to say any other reason. Those are outliers. Okay, those are outliers. So what does the definition of an outlier means? An outlier is an observation that lies outside the overall pattern of distribution. Okay, there is a pattern. Like I'll give you my example. I come from Indore, Madhya Pradesh. I came here and I'm seeing many things for my daily a daily course, or let's say I want to purchase something related to my livelihood. So chances of me getting things as per my needs with respect to my area are very less because I am here an outlier looking to my geography. But if I want to purchase from a Kerala perspective, I'll immediately get it because the overall pattern is that. And similar thing, a person who go from Kerala to other side may face it because their overall pattern will be different. So outlier is something which outlier is a type of observation that lies outside the overall pattern of a distribution. Okay, so I hope these definitions are clear to you. Now we'll proceed. Now, first we will start with the mean. Okay, first we will start with mean. So, one second. First, I'll just read about the definition, then we'll see. Mean is what? The mean is the most widely spread measure of central tendency. It is the simple average of the data set. So whatever data set I'm having, I will simply take the average of that data set. And here now I'm just taking this particular slide for ungrouped data. Here you can see ungrouped data. Okay, this is for the ungrouped data. Group data we'll see afterwards. So the mean is the most widely spread measure of central tendency. It is the simple average of the data set. Now, one important thing. It is easily affected by outliers. Okay, it is easily affected by outliers. I'll tell you slowly, you will understand what I'm trying to say. So the formula for calculating mean is summation I is equals to 1 to n xi upon n. Or if I expand this term, so I will put 1, 2, 3, 4, 5 in place of I and it will go on. So x1, x2, x3, xn minus 1 and xn. Just one bit. Sure. Yeah, we'll proceed. Okay, so summation I equal to 1 to n xi upon n, or I just expanded it. Okay, but one thing you need to keep in mind that it is easily affected by outliers. Okay, now we'll just see two examples. First one is this given series, it is without outlier 45, 25, 65, 48, 65, 98, 75, 89. So the mean straight away will be sum of all this divided by 8. So mean is 63.75. But suppose if an outlier is there. Okay, suppose one outlier is there. Here I have added 208. Okay, so you see the mean is 78.625 and here the mean is 63.75. So you see when there was no outlier, when the data was without outlier, it was more or less representing the majority of the things. 65, 65, 75, it is nearer to them. But when it is coming 78, it is directly crossing 75. Means it is representing only 2 of the data set. So because of the outlier, it is shifted from the mean. It is shifted from the central tendency, and that is what our task is. Our task is to appropriately see where our central tendency is going. Okay, where is our measure of central tendency? Okay, so I hope the definition of mean, its formula, and with 2 examples we have understand that how outlier will affect the calculation is clear to you. And this is for the ungrouped data. Okay, okay, keep this in mind. This is for the ungrouped data. Now we will see median. Now we'll see median. So what does median means? The median is the midpoint. The median is the midpoint of the ordered data set. Here, this thing you need to keep in mind. It is what? It is ordered data set. Means I cannot take it random. I have to order it in a certain order. Then I will see median. So, but one thing, it is not as popular as the mean, but is often used in academia and data science. I'll tell you when to use it. Okay. The main advantage with this is it is not simply affected by outliers. Okay, median is not simply affected by outliers. Okay, so how we calculate then median? In an ordered data set, the median is the number at the position n plus 1 by 2. Okay, the median is the number at a position. Okay, here you have to keep in mind, I'm not seeing numbers. Rather, I'm seeing the position of the numbers. Okay, there is a difference. In mean, I was seeing the numbers itself. I was doing plus minus in that only. But in median, I'm just seeing the position of that number. Okay, and then if this position is not a whole number, okay, whole number, then the median will be the simple average of the 2 numbers at position closest to the calculated value. Now I'll explain you with an example. Okay, here also I will take 2 series, one without a outlier and other with outlier. So this is our series, raw series. 45, 25, 65, 48, 65, 98, 75 and 89. Now first I will arrange all this in the ascending order. Okay, in the increasing order of its value. So I have arranged it in ascending order. 25, 45, 48 to 98. Here my number of data sets are 8, right? Number of data sets are 8. 1, 2, 3, 4, 5, 6, 7, 8. So as per this formula, my median will be 8 plus 1 by 2. That is 4.5. 4.5. So that means we have to take the average of the 4th and the 5th value, right? It is 4.5. If it is 6.5 means I'll take the average of the 6th value and the 7th value. So 4th value is what? 1, 2, 3, 4. It is 65, as you can see here. And 5th value is what? Again, it is 65. 65 by 65 by 2, it is 65. So my median is 65. Okay. Now I'll see the same example with outlier. With outlier. So my row series is this with that particular outlier added in that. Now I have arranged it in ascending order. 25 potential. Okay, in that case, my median number will be 9 plus 1 by 2 because the number of data sets are 9. So 9 plus 1 by 2 is 5. 5 is the 5th position. At 5th position, it is 65. Now I want you to observe one thing. See here, without outlier also it was 65. With outlier also it is 65. So that is why when you are anticipating that there may be a disturbance because of the outlier, instead of mean, you can use median because our sole purpose of calculating measure of central tendency is to arrive at a value which should represent the whole group. Okay, which should represent the whole group. It should not happen that we are giving a particular value which is not representing a whole group. Okay, so it is at the 5,065. So I hope median is clear to you. Of course, that when you are applying, it may not be that simple, but I have kept these values to give you the deeper insight of what could be the difference between a mean and a median. Okay. Now we will see the third one. Mode. Mean we have seen, mode we have seen. Sorry, mean and median we have seen. Now we'll see mode. What does mode means? The mode is what? The mode is the value that occurs most often. Okay, that occurs most often. Means the more a value is repeating in a set, the more it is towards the model class. Okay, a data set can have 0 modes, 1 modes, or multiple modes. So how we calculate mode? The mode is calculated simply by finding the value with the highest frequency. Now here if you see 45, 25, 65, 48, 68, 98, 100, 200. So all other values are repeating once only. All other values are repeating once only. But 65 is coming twice. So 65 is my mode. Okay, 65 is my mode. So actually mode is more prominent when you want to see the central tendency of categorical data. Okay, categorical data like car brands or something else where not much numerical values are involved. That time mode will be useful. Okay. So I hope mean, median and mode for ungrouped data is clear to you. Okay, this whatever we have seen by now, mean, median and mode was for the ungrouped data. Now we will see mean, median and mode for the group data. Okay, we'll start. Okay, so suppose one example is given to you. Class 0 to 10, 10 to 20, 20 to 30. In that frequency means in that class, 5 observations are there. So that observation may be anything. Okay, suppose it is, for example, it is related to age. Okay, 0 to 10 years, 5%, 10 to 20 years, 9, 20 to 30 years of age, 14, and so on. So this is the class, this is the frequency. Then we will calculate the center of that class. So for 0 to 10, the center will be 5, 10 to 20, 15, 20 to 30, 25, 30 to 40, 35, and 40 to 50, 45. It is simply the average of these two. So when you take average of the two, it will come on the center. Okay. So it is also known as mid class. We denote it by Fi. And this is frequency, we denote it by Xi. So what is the formula in case if you want to calculate mean for a group data? The formula is bar x is equals to summation Fi xi divided by xi. Okay, summation Fi xi divided by xi. So what we will do? First, we will see frequency, that is 5 for 0 to 10 group, and the mid class is 5. So 5 into 5 is equals to 25, right? Then 9 into 15, 135, 350, and so on. The total of all this is 2155, 2155. So this is basically the summation Fi xi. Okay, this is basically the summation Fi xi. And our xi will be this one, 69. So 69 is my xi and 2155 is my summation Fi xi. So I will divide 2155 by 69. It is the answer is 31.23. So my mean for this one is 31.23. Okay, I hope this is clear to you. This is for the group data. Group means already there are some classes. In that I know their frequency, but I don't know the exact value. Like in 0 to 10 years of age, I know 5 students are there. But out of those 5, how many are of 11 years of age? How many are 13 years of age? Who are 15 years or 16 years? That I don't know. I know only 0 to 10. So that data is already grouped. And many times we need data grouping because ungrouped data may be too huge. Okay, if you go and collect ungrouped data, it will be too huge. So you have to make it in groups. Then you can carry out your analysis. Okay, we'll proceed. Second one is the mean we have seen. Now we will see median. Median for group data. So the formula for calculating median for a group data is, I will explain you one by one. You just be cautious, especially the ones whose names have been taken last time. So the formula for median will be MD is equals to L plus N by 2 minus CF upon F into I. MD is the median Small s is the lower limit of median class. Okay, lower limit of median class. I'll tell you how to see median class. Then CF is the total of all frequencies before median class. Okay, CF is total of all frequencies before median class. F is the frequency of median class and I is the class width of median class. Class width means its interval. Like in previous example, it was 0 to 10, then 11 to 20. So that 0 to 10 was the class width. 10 is the class width. Okay. One by one, I'll show you, you will understand. Now, question. Find the median for the following distribution. So there is one row in which it is given wages in rupees. 0 to 10 rupees, 10 to 20, 20 to 30, 30 to 40, and 40 to 50. And in that wage, number of workers. There are 22, 38, 46, 35, 20. Actually, the example I have taken from an old book. That's why 10 rupees was more that time. So just bear with it. So 0 to 10, number of workers 22, 10 to 20, 38 and all. Now, how to proceed? When you are calculating median for a grouped data, ungrouped, there is no problem. We will simply do n plus 1 by 2. When you are calculating median for a grouped data, you have to first create a cumulative frequency table. Okay, so first we will arrange all those things 0 to 10, 10 to 20 and all. Then we will arrange number of workers 22, 38, 46, 37, 20. Then we will create its cumulative frequency. Okay, we will create its cumulative frequency. So 22 is here. That is okay. Then in second time, I have to add 22 plus 38. You can see here. So 22 plus 38 is 60. Then I will add 60 and 46. So 60 and 46 will be 106. Then 106 plus 35 will be 141 and so on. So total there is the total cumulative frequency is 161. It is just a sum of the previous frequency plus the present frequency. Okay, up to this point, I hope it is clear to you. Now, before applying the formula, we need to see the median class. Here you can see, and now I'll start one by one. The first point is we need to see lower limit of median class. Okay, we need to see lower limit of median class. How we will see? Here the total cumulative frequency is 161. Okay, total cumulative frequency is 161. As you can see here, 161. So therefore, we know that median is the measure of n plus 1 by 2th term. So if I divide n plus 1 by 2, it will be 81. Okay, 161 plus 1, 161 plus 1 will be equal to 162. Okay, 162. And if I divide 162 by 2, it will be 81. So 81st term. Now, if I go in my table back, I can see that 81st term will be situated in the class 20 to 31. You see here, up to here, it is 60, right? You can see here, it is 60. No, so 81 is greater than 60, but less than 106, right? So the class will be lying in 20 to 30. Okay, that class, that median value will be lying in the range of 20 to 30. Okay, I'll just explain you one more time. I did n plus 1 by 2 and that n plus 1 by 2 is coming as 81st term. Now 81st term for sure it is greater than 60. So I cannot take this class where 60 lies 10 to 20. So of course naturally it falls in the next class. The next class is what? 20 to 30. So my median class is 20 to 20, 20 to 30. I hope up to this point it is clear to you. My median class is 20 to 30. Now I will apply my formula. Median formula is MD is equals to L plus n by 2 minus CF divided by F into I. Now my L is what? L is lower limit of the median class. What is my median class? Median class is 20 to 30, right? So in 20 to 30, 20 is the lower limit of the class, 30 is the upper limit of the class. So in place of L, I'll put 20. Okay. So L is my lower limit of the median class. Now n by 2 I very well know. N is my number of data set. It is 161. So 1 by 2 into 161 minus cumulative frequency in that class. So if you go back, what is my is CF? CF is total of all frequencies before median class. Okay, before median class. What is my median class? Median class is 20 to 30. Before that, what is the cumulative frequency? 60. So I will put 60 in place of CF. Divided by F. F is what? F is frequency of median class. In median class, what is the frequency actual? It is 46. So I will put 46 here. And I is what? I is my interval. All right. I is my interval 0 to 10, 10 to 20. It's my interval. So I put 10 here because there is a difference of 10, 10, 10 in each. So it is 20 plus 205 by 6 is equals to 20 by 20 plus 4.46. My answer is 24.46. So my median is 24.46. Okay, I hope this is clear to you. Even if it is not clear in assignment, it will be clear to you. Okay, great. Now we will go ahead. Now we will see mode. Now the formula for mode is before that, up to this point, any doubt? I don't want to go any fast. You can ask me. Or anything which just like that gone like bouncer. You want me to repeat? I can repeat. Okay, we'll proceed. Now we will see mode. The formula for mode is m naught equals to L plus f1 minus f naught divided by twice of f1 minus f naught minus f2 into I. Here L is lower limit of the class. Now since I'm calculating mode, here lower limit refers to the model class. Okay, mode. Then f1 is frequency of the model class. F naught is frequency of the class just preceding to the model class. Means just before that. F2 is frequency of the class just following the model class, means after that. And I is the class interval, which you know it is the difference between the lower limit and the upper limit. Okay, now we will see one example. Okay, so now compute the mode of the following distribution. Class is given 0 to 7, 7 to 14, 14 on this, and frequency is given 19, 25, 36, 72, 51, 43, 28. So here first we need to see. Now you understand in median we have seen n plus 1 by 2, but in mode we don't do like that. What is mode? By definition, mode is the most frequent value. So here we can clearly see the most highest frequency is 72. Okay, the highest frequency is 72. So here our maximum frequency 72 is the model class. So our model class will be 21 to 28. Okay, 21 to 28. So our maximum frequency lies in 72 and the class interval is 21 to 28. Therefore, 21 to 28 is our model class. Okay, 21 to 28 is our model class. So here now we will see one by one. First, we have to see this point L. L is what? Lower limit of the class. Lower limit out of this is what? 21 naturally. So 21 is my L. Then F1. Frequency of the model class. Frequency is what? 72. So my F1 is 72. Then F0. Frequency of the class just preceding of the class, means just before that. Here it is 36. Means frequency just before the model class frequency. It is 36. And F2 is what? F2 is frequency of the class just after the model class. It is 51. Right, it is 51. So F2 is 51. And I is what? I is class interval. So you can see there is a difference of 7 in that. 0 to 7, 7 to 14, 14 to 20, difference of 7, 7, 7, 7. Okay. Now we have calculated all the things. We have means we know all the things. And now we'll put this in the formula. Now our m naught is 21. That is the lower limit of the class. Sorry, L. L is 21. Then F1 is 72. F naught is 36. Twice of F1. F1 is 72. Then minus 36 minus 12 into 10. So 21 plus 357 by 87. It is coming 25.103. You can check if some calculation error are there, but the method is this. So I hope up to mode, it is clear to you. Ria Martin, are you there? Ria Martin.
Yes, sir.
So Ria, can you just briefly explain what is the difference between grouped and ungrouped data, and in what situation we should collect it? Ria, I'm not able to hear you. Sophie Mariam V, are you there? You able to hear me, Sophie?
Yes, sir.
Okay, can
Hello.
you just tell us the difference between grouped and ungrouped data, and in what situation we should collect it?
For an ungrouped, for a grouped data, already there are some classes, and we know we know only the frequency, but not the exact value.
Good.
So we consider for grouped data, we have only an particular interval like 0 to 10, 10 to 20, like that. But in ungrouped data, we have particular there is a value corresponding to that. For example, if there is a group of students, and they are securing each one have a particular marks, and for calculating a mean we take the average. But in the case of grouped data, there is only a class, and for a particular class there is a frequency. We don't know the exact value, so we multiply that frequency with that mid value of that particular class, and we divide with the total number, then we can get the mean value. Like that, we can similarly in median or median and in mode also.
Okay, Sophie, actually this you have explained. The second thing I asked, in which situation you will collect ungrouped data and group data? What will be the condition? You have explained very well about the grouped and ungrouped, but in what situation you will collect it, or how you will proceed? I think Sophie, Sophie, wait. You have explained from your side. Sridevi, you able to hear me? Sridevi?
Hello, sir. Hello, sir.
Sridevi, can you tell me the difference between mean, median, and mode? Briefly.
Sir, in group data or in ungrouped data,
No, Sridevi, I'm asking about difference between mean, median, and mode. Not grouped and ungrouped.
Okay. Mean, we will see the simple average of that whole data set. In case of median, we will see the midpoint of ordered data set. That is, when we are arranging the data in an order, we will see that midpoint. In case of mode, the value which is repeated most often times considered as mode.
Okay.
Hello.
Okay, Sridevi.
Hello.
Sridevi, okay.
Sir,
Raj
thank
Singh,
you.
are you there? Raj, are you there? Raj Singh.
Yes, sir. Yes, sir.
आवाज आ रही है राज मेरी?
Yes, sir. Yes, sir. आ रही है सर.
ओके. ये मीन, मीडियन और मोड में क्या डिफरेंस है? श्रीदेवी ने जो बताया वो प्रोसेस के बारे में बताया. फंडामेंटल डिफरेंस क्या है मीन, मीडियन और मोड में?
सर मीन में हम लोग एवरेज निकालते हैं सर. सर इन मीन we can find out the average between the data, And median में sir we can find out the mid value of that frequency. And mode में sir हम लोग highest frequency निकालते हैं sir उसका.
No, it is okay. It is about the process. Sridevi already briefed this. Why we do like that? Why we when we have mean, why I need median and mode? That is what the difference I'm asking.
Saurav sir,
Yes.
Balan here. Can I give the
Alan,
answers?
go ahead. Please go ahead.
Sir, actually, mean is not affected, is highly affected by the outliers.
Yeah, correct.
Median and mode is not affected by outliers.
Yeah, correct.
This is the major difference.
Yes. It is what I was asking. Good, Alan. Okay. Okay, then we'll proceed now. For the next time, Gopika ji, Gauri Krishna, Hari Krishnan, Iba S, Dia Malik, Delna TS, you may be prepared. I'll ask you next time. We'll proceed. Okay, so it is just an analogy that tell me I'll forget, show me I'll remember, and involve me I'll understand. So I'm following the third point, and for sure in the next classes we'll follow third point only. I'll involve you so that you will understand. Only thing is that you need to keep the necessary patience. Okay, now we will see partitions. Okay, not the India-Pakistan partition, but the statistical partition. So why we need partitions and why partitions are important, that you will understand in next 10 to 15 minutes, and you will be amazed that in a single data set, how effectively from different perspectives you can infer or you can draw different types of conclusions. You will be amazed to see. Now we will see about the partitions. So before I start with partitions, first you understand one more time what median was. What was the median? The value of the variable which divides the data in two parts is called a median, right? Median was divided in two parts, n plus 1 by 2, and we will divide it in 2. But what we can do is that we can divide our data in other proportions also. Most importantly, we divide it in three parts after mean and median: 4, 10, and 100. Okay, 4, 10, and 100. So if I'm dividing it in 4 parts, it is quartile. Okay, if I'm dividing it in 10 parts, it is decile. And if I'm dividing it in 100 parts, it is percentile. Okay, so I hope it is clear to you. Quartile, decile, and percentile. All these are together collectively known as partitions. Partitions. We are just doing partition within the data to get more insights out of it, to get more conclusions, so that I can make my thesis or my scientific study more authoritative, that yes, I know my data in and out. Okay. So we will see 4 parts quartile, 10 parts decile, 100 parts percentile. Now we will see one by one. Suppose this is my whole data set. This black line is my whole data set. Okay, and I have divided my data set in 4 parts. 1 by 4 one part, second wala 1 by 4, third wala 1 by 4, and the fourth one is 1 by 4. Okay, 1 by 4, 1 by 4, 1 by 4, and 1 by 4. So if I'm seeing the data from the first 1 by 4, I will call it lower quartile, Q1. Okay, I will call it lower quartile, Q1. And if I'm seeing it after 3 1 by 4th, you can see here, I will call it, or I will say it, upper quartile. Okay, if you see in percentage, 1 by 4 means 25%, right? If something is 100%, its fourth part will be 25%. So when I'm seeing after 25%, it is lower quartile. And if I'm seeing after 75%, it is upper quartile. Okay, now we will see what is the formula for this. So if I wish to calculate lower quartile, the formula will be L plus n by 2 minus Cf upon f into I. Okay. And upper quartile will be L plus 3 by 4 n minus Cf upon f into I. And these symbols are same as what we use in the median formula that you will understand anyway. Q1 equal to L plus n by 4 minus Cf upon f into I, and Q3 equal to L plus 3 by 4 n minus Cf upon f into I. This is for quartile 1, this is for quartile 3. Now, deciles. What does deciles means? Is the name indicates. Deci means something 10. Okay, in parts of 10. We say na deci. Deci means something 10. So the values of the variable which divides the total frequency into 10 equal parts. Okay, when I am dividing in 4 equal parts, those are quartiles. When I am dividing it in 10 equal parts, those are decile. Okay, so I will just see the formula. D1 equal to L plus n by 10 minus Cf upon f into I, and D2 equal to L plus 2n by 10 minus Cf into f into I. Now I want you to observe one thing. Formulas are more or less same. When I'm doing for quartile, I'm using by 4 because I'm dividing it in 4 parts. Naturally, I'll use 4. When I'm doing deciles, I'm dividing it by 10 because it is a decile, right? So 10. The third one is percentiles. As you know, cent means 100, right? Cent means 100. So the values of the variable which divides the total frequency into 100 equal parts is known as percentiles. You would have heard by now that in GATE exam my percentile was this and this. So it is what that percentile is. So P1 equal to L plus n by 100. Now since it is percentage, I am taking 100. P1 equal to L plus n by 100 minus Cf upon f into I. And suppose if I want to calculate 70 percentile, 70 equal to L plus 70 by n into by 100 minus Cf upon f into I. Likewise, I can calculate any percentile. Okay. Now I want to explain you one thing. There is a fundamental difference between percentage and percentile. Okay, there is a fundamental difference between percentage and percentile, and that some of you will tell me, some of you I will ask two things tomorrow. Keep this in mind and you have to answer me. First is what type of data you are generating in your experiment. With justification, you have to tell me that this is my data and my data is interval quantitative this, discrete nominal this, that you have to categorize. And second one is difference between a normal percentage and a percentile with example. Both things you have to explain with real life example. Okay, we'll go ahead. Now the example. Compute the lower and upper quartile, 4th decile and 70th percentile for the following distribution. Okay. Lower and upper quartile means Q1, Q2. 4th decile means D4. And 70th percentile for the following distribution is P70. So the table is given like group of marks 5 to 10, 10 to 15, 15 to 20, 20 to 25. Number of students this. Then marks to group 25, 30, 30, 35, 40, 45, 5, 4, 2, 2. Okay. Now first what we will do. First, as usual, we will create one cumulative frequency table. So these two columns will be same. Then we will make one cumulative frequency table. So 5, then 5 plus 6, 11, then 11 plus 15, 26, then 21 plus 10, 36, then 36 plus 5, 36 plus 5, 41, 41 plus 4, 45, and so on. Last cumulative frequency is 49. So this table we have created. Now we will apply our formula. First, we will compute quartile 1. So every time whenever we are computing this, we need to see that particular class, in which class it will fall. So to compute Q1, here we know that total frequency is 49, right? The total data is 49. So here n is equals to 49. So since it is quartile, and in quartile we divide our data by 4. First I'll divide my data by 4. Okay, so 1 by 4 of 49 here 4 somehow it is not come, it is missed. 49 by 4 is 12.25. Okay, 12.25. So of course, if I see 12.25, 12.25 will come in here, like it is greater than 11, right? Greater than 11. So it will fall in this class, 15 to 20. Okay, it is lies in 15 to 20. Thus, 15 to 20 is a lower quartile class. So here is the lower limit of the quartile class, which is 15. We can see here. Then cumulative frequency, just one class above that class is 11. You can see here 11. That is CF equal to 11. F is frequency in that class here in center. 15. And interval I is 5. 20 minus 5 because 5 interval are there. 5 to 10, 10 to 15 like that. 5. Now I'll apply my formula. So Q1 equal to L 15 n by 4 minus CF upon F into I. So it is coming 15.417. Okay, 15.417. Now we'll see Q3. When I'm seeing Q3, I have to multiply my data by first 3 by 4 because it is third quartile. So if I multiply 49 by 3 by 4, it will come 36.75. Okay, 36.75. Now if I go back and see 36.75, 36.75 will lies after this class. This 20 to 25 class. So it will be in the 40 class in which cumulative frequency is 41. So this is 25 by 30. So my third quartile class is 25 to 30. Now here lower limit of the class is 25, L equal to 25. Cumulative frequency is 36. You can see here one class before that class is 36. Then frequency, just one class before that class is also in that class 20 to 30 class is 5. You can see here 5. F is 5. I is of course 5. So I put all these values and the answer is 25.75. Now I want you to observe one thing. When I'm saying my quartile 1 is 15.417, then I'm saying like these are marks, right? These are marks. I'm saying that 25% of the students are having marks less than 15.417. That is what interpretation I will make. Out of the total student, 25% of the students are having marks less than 15.417. Or other way, I can say, I write here 25% of the total students having marks less than 15.417. 15.417. Okay. And if 25% are less means other 75% students are having marks greater than 15.417. Right. So this is how partitions led you to generate or to see more insight. Now if I see Q3 quartile 3, it is 25.75. So I will say that 75% of the students in the class are having marks less than 25.75 and that 25% of the students are having marks more than 25.75. So that means middle 50% are having marks less than this one and this one. If I divide 25, 50 and 75. So 25, 75 we have seen less than this, greater than this. So remaining 50% are having marks between this and this. Now you see the beauty of statistics and the power of computation. Just with this table, when you don't know which students are having what type of marks or how many students are this and this, still you are able to tell the percentages. That is where the power of computation and mathematics comes. Okay, I hope this is clear to you. If not, if it is not clear to you, you can very well ask me. Anyway, if you don't ask me, I'll ask you after some time. Third one, decile. So now here they have asked for the decile 4, D4, right? So to compute D4 here, now you have to apply your mind. When I was doing quartile, it was 1 by 4. When I'm doing third quartile, it was 3 by 4. Now when it is decile, naturally it should be starting 1 by 10. And if it is third, fourth or fifth decile, multiply by that. So if it is fourth decile, means it will be 4 by 10. Okay, 4 by 10. So here our decile class will be 4 by 10 into n. Our n is 49, right? 49 cumulative frequency. You can see that is common for all. 49 here. So it is 19.6. Now if I go back in my table and if I see 19.6, so 19.6 again it is greater than 11 and less than 26. So it will fall in the 15 to 20 class. This one. 15 to 20 class. So here again my lower limit of the class is 15 and cumulative frequency one class before that class, that is 11, right? That is 11. You can see here that is 11. That is 11 and frequency in that class itself is 15. Okay, you can see here in 15 to 20 it is 15 and my interval of course I is 5 and I is 5. I is 5. So my formula is D4 equal to L plus 4n by 10 minus CF upon F into I. 15 plus 17.87. Okay, 17.87. So this is my decile 4. Now I want you to observe one thing. This is quartile 1. Quartile 1 value is 15.417, right? 15.417, which is 25%. Now D4 is 40%, right? So naturally 40% should come more than 25. So here I can say that 40% of the student in the class are having marks less than 17.87. Naturally, and of course, since 2 marks are increased, you can see here, here it was 15.417 marks. Here it is 17.87 marks. So means when I'm increasing 15% of the students in the class, of course, marks will also increase. So by increasing 2 marks, I can say that 40% of the students are having less marks than 17.87%. And naturally, then remaining marks remaining are 60% are greater than this. Okay. Now we will see P70 because in the question it is also asked to calculate percentile, 70 percentile. So of course, now when I'm calculating 70 percentile, I will do 70 n by 100, right? 70 n by 100. So 49 into 7 by 10 is 34.3. So if I go and see 34.3, 34.3 will come in this class, 20 to 25 class. Okay, 20 to 25 class here. So naturally 20 to 25, my lower limit will be 20. Cumulative frequency just one class above that class is 26. Frequency is 10 in that class. You can see here it is 10. And I is 5. So P70 equal to L plus 70 by 100 into N minus C upon F into Y. I put all the values and it is coming 24.15. Now I want you to observe one more thing. This is 70 percentile, right? 70 percentile. Earlier we have calculated Q3, quartile 3. So see that was 75%, right? So it is slightly 1 or 1.5 marks above than the 70. It is 25.75 and this is 24.15. So if I reduce one more mark from this, I can say that 70% of the students are having marks less than 24.15 and remaining 30% are having marks more than 24.15. So I hope quartile, decile, percentiles, all these things are crystal clear to you. 5 people has left the class. Anyway, I'll be taking attendance. I'm very particular about attendance. Okay, so you have to be in the class. Lakshmi Shaji, are you there?
Yes, sir.
Okay, so can you tell me 2 or 3 benefits of doing partitions of our data set? I'm not able to hear you, Lakshmi.
I'm sorry, sir.
Okay. Then what you can speak about it. If you don't know this about this, what you understood in last half an hour, you can brief us about that.
So we have different kind of partitions like quartile, decile, percentile. So first of all, speaking about median itself, we know that median is actually the value which is dividing the data into two parts. So likewise, we can divide the data into different parts, like maybe 4 parts, 10 parts, 100 parts, etc. So dividing into 4 parts, we call it as quartile. 10 parts it's decile, and 100 parts it's percentile.
Okay.
So it will be more easy to analyze.
Okay, good. But you be attentive from now onwards.
Yes, sir.
Okay. Rumaisa NM, are you there? You able to hear me?
Yes, sir.
You able to hear me, Rumaisa?
Yes, sir.
Okay, so can you tell me a real life example of partitions?
You already said, sir, gate score.
No, that was by me. Now you say, now you just give idea from your side. And that was particular for percentile. I'm just in general I'm asking. Some real life example of doing partitions. Okay, no issue. Isak, Manoj, are you there?
Yes, sir.
Okay. So you just brief me in 1 minute what you understood from partitioning of the data.
Sir, actually, partitions means we can divide our whole set of data into all set of data into different parts, and we can analyze them to get more information from them. So that's what we are for that only we are doing these partitions.
Okay, good. Okay, then we'll proceed. So by 6, I'll leave you. More 25 minutes. Okay, so up to this point, we have finished our today's class regarding descriptive statistics. And now we will see some further things. Okay, so first we have seen measures of central tendency. Second time we have seen measures of partition, right? Now we will see measures of symmetry. Okay, now we are seeing measures of symmetry. So when I speak about measures of symmetry, the main important point what we refer to is the skewness. Okay, it is the skewness. So what does skewness means? Skewness indicates whether the data is concentrated on one side. Okay, we see in this that whether our data is concentrated on one side. So there are 3 types of skewness, and this you will come to know after plotting your histogram. I know, I hope histogram you know very well how to plot it. And even if you don't know, you just refer to my YouTube videos and you just go through it, listen to it attentively. This recording also will be available. And in assignment, one question is there to make histogram. That time you will come to know. So first one is positive or right skew. Okay, positive or right skew. So this kind of condition occurs when our mean is greater than our median. Okay, I hope you very well know now mean, median and mode. Okay, that you should not have any doubt about it. So when our mean is greater than median, the data is called as positive or right skew. In those cases, the data will be concentrated on the left side and there will be a skew or a flat line on the right side. That's why it is called positive or right skew. And sometimes there may be outliers also. Okay, sometimes there may be outliers also. So that kind of data is known as positive or right skew. Okay, when the mean is greater than the median. The second one is zero or no skew. Zero or no skew. So this is the ideal condition which never happens. But of course, we measure all our things related to some benchmark or some kind of ideal situation. Okay, so we calculate like this. When our mean is equal to the median and both are equal to the mode, mean, median and mode are equal, then the data or the histogram what we obtained is called a zero skew. Means it is very properly distributed. You can see first bar, second bar, and then uniformly distributed. So this kind of data or this kind of symmetry is known as zero or no skew. Okay, so positive or right skew we have seen, zero or no skew we have seen. Third one, negative or left skew. It is or, it is not off, है ना? Negative or left skew. So in this case, in first case, my mean was greater than median. Second case, mean, median, mode all are equal. In third case, mean is less than the median. Okay, mean is less than the median. So here right side more data will be concentrated, on left side data will not be concentrated and some outliers will be there. So that's why it is known as negative or left skew. Okay, so this you will only come to know after plotting histogram. There are some formulas are also there for measuring symmetry, but to my experience, it is not required that much. That's why I follow only the histogram part. Okay, that's why I'm also recommending you to follow histogram part. Now, this was about measures of symmetry. Okay, now we'll see one very important point. Measures of dispersion or variability. Okay, this is very important. You have seen measures of central tendency. You have seen measures of central value. You have seen partitions. But many a times you should know how much variation can occur when you are doing a particular task. Suppose you and your family is going for a tour. Okay, you have estimated some amount that this much for hotel, this much for car, this much for traveling, this much for food and all those things. But still you always keep some money extra on a safer side. Then no, my friends have gone earlier and they said that this and this contingency money will be there. Actually, that extra money is the deviation from your central value. Let's say central value is 50,000, but you kept 20,000 extra for any other deviation. That is what dispersion is. That is what variability is. Okay, one thing. Second thing, many times you would have observed if you are crossing a river. Okay, if you are crossing a river, or if you have sometimes stopped at a particular bridge near a river, or you have seen something like that, you will see a board that the depth in this river is like 3 meter plus minus 0.5 meter. Okay, 3 meter plus minus 0.5 meter. What does this mean? So in that, 3 is the central tendency, 3 is the mean value, and plus minus 0.5 is the deviation. So at some point of time or at some place in the river, the depth may be 2.5, that is 3 minus 0.5, and some point of time it may be 3.5 also. That's why 3 plus minus 0.5. So that deviation we will keep it in mind. That is how measures of dispersion or variability work. And this we should very well know. Okay, we should know the deviation in our data so that accordingly we can frame our measures to go ahead. Okay, now we'll talk about the understanding of the definition. What does the definition of this data means? An average gives an idea of the central tendency, right? Average gives an idea of the central tendency, but it is always necessary to know how variables are clustered around or scattered from the average. This 2 is not required actually here. Okay, how variables are clustered around or scattered from the average, and also how I can define it. The degree to which numerical data tend to spread about an average value is called variation or dispersion, or spread of the data. Means one average value is there, but still it can vary. Okay, so it can vary. I hope it is clear to you. In your case also, many times it would have been happened that you have conducted some experiment, you have generated some data, but your supervisor would have told you that this is not an usual value. The usual value should be between this and this. You should repeat your experiment. There is some human error. That is how variation or dispersion comes into account. Now, the first measure of dispersion is the range. Okay, first measure of dispersion is the range. So what does a range means? Range is the simplest measure of dispersion, or simplest measure, and it is simply the difference between the largest and the smallest number for a given set of number. In that particular data set, it is the difference between the largest and the smallest number. So suppose range is 15, 20, 25, 30, 35. So highest number is 35, lowest number is 15. Okay, so 35 minus 15, 20. 20 is my range. So I can say that maximum is 20, minimum is maximum is 35, minimum is 15. So my range is 20. Second one is the interquartile range. Interquartile range is upper quartile minus lower quartile. This I told you earlier, that when I minus 75 to 25, I can obtain the middle 50% of the students. Right? I told you earlier, if you remember. If I minus Q3 from Q1, the value I'll be getting is corresponding to the middle 50% of the students. So it is known as interquartile range. Now semi-interquartile. Suppose I want more precise deviation from the center. So what I will do? I will simply divide it by 2. So upper quartile minus lower quartile, I simply divide it by 2. So I will get the center 25%. 12.5% on the other side of the mean and 12.5% on the other side of the mean. That is known as semi-interquartile range. Okay, I hope range, interquartile range and semi-interquartile range is clear to you. Variance. Now for variance, there will be two different formulas. Two different formulas for variance. Okay, now I hope you very well know that what is a sample and what is a population. Okay, so for sample data, the formula for variance will be different. For population data, the formula for variance will be different. Now, when you take sample data, you very well know that when we take a sample data, 10 different samples may give us 10 different measures or values. Right? 10 different samples may give us 10 different values or measures. And when you are taking mean, what you do is that when you are calculating mean for a sample, you divide by the number of sample, and when you are doing for the population, you divide by number of population, capital N. Okay, here this I am showing you for a reason. You will come to know. Okay, so 2-3 things to keep in mind. Variance will be different for sample and population. Okay, if you are taking 10 samples, they may give you 10 different values, and mean also different for sample and different for population. Now, what does variance means? If you see from a data perspective, suppose this is your mean, this center, Anna, this is the mean, and this is our data. These 2-3 data points are this, 2-3 data points are this, 2-3 data points are this side, 2-3 data points are on this side. So what does variance means? Variance measures the dispersion of a set of data points around their mean. Let's say this is particular data D1, and the mean of the D1 is this one. So this is the variance of all the data around its mean. Okay, that is variance. Now variance will have two different formula. I told you earlier, variance will be different for sample, variance will be different for population. Okay, this question I have asked in assignment also. So I may not be telling you why we do -1 here. That is your job to work out. I'll tell you afterwards. So in case of population, we denote variance by sigma square, and we denote in case of sample we denote variance by s square. It is summation I equal to 1 to n xi minus mu. Mu here is our mean square, and formula is same, but in population we denote it by mu. Mu is population mean. Okay, mu is population mean, this one, and bar x is sample mean. Mu is population mean, bar is sample mean, but the difference is here we as it is keep the number n, number of population, but when it comes to sample we deduct 1 from it. That you have to tell me. It is already there in the assignment why we deduct 1 from the number of samples when we calculate variance or standard deviation for a particular sample and population. So I hope the formula for variance is clear to you. Now one thing. Now one important thing. Okay, this slide is not required. Now one important thing. Now we will see standard deviation. Okay, we will see now standard deviation. So I hope variance is clear to you here. Different formula for population, different formula for sample. Now standard deviation. So what I will do, I will just simply take a square root of variance. Okay, if I am taking a square root of variance, it will become standard deviation. Okay, so if I am doing for sigma, it is standard deviation for population. If I am doing for sample, it is standard deviation for sample. Now why we did it? You just simply think that you are calculating variance for speed. Okay, you are calculating variance for speed. Now you see here in variance, there is a square in the formula. Okay, there is square in the formula. So the units of this output will be in square, kilometer square or kilometer per second square or other. So you yourself think, can the speed of meter per second or kilometer per hour be in squares? No, it cannot be in squares, right? So what I will do, I will take a square root of it. Once I take a square root of it, my units will be homogeneous and logical. Okay, my units will be homogeneous and logical. Now then you will ask me, if that is the case, at first place why we calculated variance. So the more the value of variance, it will give a picture of how data may vary irrespective of the unit of that particular thing. Maybe it is kilometer or meter per second, kilometer per hour, or anything. The more the value, it will just give us an idea. But when we are actually quantifying it, we will take a square root of it. Okay, we will take a square root of it. So it will give the deviation, that too in same units what it should have been at the first place. That is what the application of standard deviation. Okay. Now one more question you may ask. Okay, I don't want a clear picture, of the data. I just want quantitative values. But from a mathematics point of view, also when I'm deriving standard deviation, I cannot come to standard deviation without doing squares of it. So somehow we have to cross variance. Somehow we have to cross variance always. That's why we have taken square of it. Now, coefficient of variation CV. Coefficient of variation CV. What does it mean? It is what? It is relative standard deviation. In YouTube videos in part 5 or part 6, I have taken one example. That example I will not be taking it here, but that may come in exam with changed numerical value. So you should see it. Okay. So what does coefficient of variation means? It is relative standard deviation and it is equal to standard deviation by mean. It is simply standard deviation by mean. That is coefficient of variation. Okay, so suppose sigma is population standard deviation, mu is population mean. So I'll divide population standard deviation by population mean. I'll get CV, coefficient of variation for population. And suppose S is sample standard deviation and bar X is sample mean. I will divide it. I will get CV cap. CV cap is coefficient of variation for sample. Okay, this is standard deviation, this is mean. You can see here standard deviation by mean. So if it is for population, sigma by mu. If it is for sample, is by bar x. Now, you should understand when we use standard deviation and when we use coefficient of variation. Okay, so standard deviation we use when we are seeing variability in a single data set. Okay, there is only a single data set. In the data set itself, I am seeing the variability. But if suppose two or more data sets are there and if I want to see the variability in the data set, I will use C, coefficient of variation. Okay, so CV we use when there is more than one data set, two or more data sets, and I want to see the variation between them. But if I want to see within that, it will be standard deviation. So I hope the use of standard deviation and coefficient of variation is clear to you. Now we will see one last example. Okay, the owner of a particular restaurant, the name of which I can't pronounce, is interested in how much people spend at the restaurant. They are interested in how much people are spending at the restaurant. And he examines 10 randomly selected receipts for parties of 4 and write down the following data. 45, 50, 38, 96, 42, 47, 40, 49. This is the spending. So the question is, after the spending, find the arithmetic mean and find the variance and the standard deviation. Okay, find the arithmetic mean and find the standard, find the variance and the standard deviation. Now, first what we will do, we can take the arithmetic mean directly by summing all of them and divide by 10. These are 10 values, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I'll sum it all and divide by 10. So the bar x is 49.2. Bar x is 49.2. Now I will calculate standard deviation. Now you should keep in mind that he has taken 10 randomly selected receipt. Means it is not for the whole population. It is for the sample, right? Because in a day, hundreds of customers would have come and gone, but he has taken selected 10 randomly. So that is means he has collected sample. Okay, that's why I'll be calculating sample standard deviation. So in the standard deviation formula, we know that I have to minus mean from each value. Then I have to square it and sum it divided by n minus 1. So what I will do, I will 49.2 I have already calculated. First I will deduct this 49 from all x values. 44 minus this, 50 minus this, all this came. Okay, then after this deduction, I will do square of this. Okay, minus 5.2 square, 27.04, 11.2 like this. Then I will sum it up. So I will get the first numerator. Summation I equal to 1 to x, xi minus bar x ka square. This I got. So first I will calculate variance. Here you can see we have taken 9. Sample points are 10, but we have taken 9. Why we deducted minus, that you have to tell me tomorrow. And it is also there in the assignment. So hence the variance is s square equal to this. And the standard deviation of course will be s square root of 289, which is 17. Okay, square root of 29, which is 17. So what does it means? What this means is that most of the patrons probably spend between 49.20 minus 17, right? That is $32.20 and 49.20 plus $17.66. That is what I was trying to tell you that time, that when you are crossing a river, you may see that the depth of the river is 3 plus minus 0.5. Right, so 3 minus 0.5, 2.5, 3 plus 0.5, 3.5. So the average people is spending between $32 to $66. That is what his observation is. Okay. So still 41 are there. You should not leave in between. Okay, so now I would like to just in 2-3 minutes, I would just like to take a feedback from you, whether you are able to understand things or not. Anyone? feel free to give comments. We have improved it because of feedback from last batch. Come on. At least 1 or 2. Otherwise, I'll name it. Fatima Riaz, are you there? Fatima, are you there? Okay. Gopika ji, are you there?
Yes, sir.
So Gopika, give your feedback. How was the class? Whether you were able to understand or otherwise, what
Yes,
changes
sir.
I should make?
Sir, I'm able to follow you, sir.
Okay. All the things you were able to follow? Gopika ji.
Sir?
Go ahead.
Yes, sir. All the portions I'm able to follow, sir.
Okay, good. So, okay then, this is all for today. Don't leave. This assignments, 3 more assignments will be there. It looks lengthy, but it is not lengthy. So the system will be like, there will be 20 marks for all the assignments, 20 marks for your discussion with me. After all the assignments, I'll just discuss with you. It is like a viva. Okay, don't think that you will attend the class and you will write the exam and it will be pass. It is not like that. I will check your understanding and whether you have actually attend some understanding out of this class, and remaining 60 will be for the exam. So 4 or 5 more classes will be there and this subject will be finished. Okay. Anyone would like to say something? Or otherwise we'll pick up for today. Okay. Okay, then you all can leave. Have a nice day.
Thank you, sir.
Thank you,
Welcome.
sir.
Thank you, sir.
Welcome.
Thank you, sir.
Thank you, sir.
Thank you, sir.